cross product of two vectors. In this module, you will learn to find out the cross product of two vectors. According to the right-handed rectangular coordinate system, when the fingers are curled from positive x-axis towards positive y-axis, the thumb of the right hand points in the direction of positive z-axis. Cross product of non-zero vectors A and B is defined as the product of the magnitudes of vector A and vector B, sine theta and unit vector n, where theta is the measure of smaller angle between vectors A and B, and unit vector n is a vector perpendicular to vectors A and B both. Product of the magnitudes of vector A, vector B and sine theta represents the magnitude of vector A cross vector B, and the unit vector n represents the direction of the vector A cross vector B. Notice that cross product of two vectors gives another vector, and hence it is also known as vector product. Vectors A, B and unit vector n form a right-handed system, that is, if the fingers are curled from vector A to vector B, then the thumb of the right hand points in the direction of unit vector n. Since vector A cross vector B lies in the direction of unit vector n, vectors A, B and vector A cross vector B form a right-handed system. The previous discussion helps us to conclude that if theta is the angle between the vectors A and B, their cross product is the product of the magnitude of vector A cross vector B and the unit vector n, which is in the direction of vector A cross vector B. Vectors A, B and n cap form a right-handed system. Now, consider the fingers are curled from vector B to vector A. Then, the thumb of the right hand points in the opposite direction to unit vector n. This helps us to deduce that vector B cross vector A will have opposite direction to that of vector A cross vector B. Thus, cross product of two vectors is not commutative. The value of theta is not defined if either of the vectors is a zero vector, and in such case, vector A cross vector B is zero vector. On the contrary, if A and B both are non-zero vectors, such that their cross product is zero vector, then angle theta between them is 0 degrees and the two vectors are parallel to each other. The cross product of a vector with itself is always a zero vector, as the value of theta between two identical vectors is 0 and sine 0 is equal to 0. Also, the cross product of a vector with its opposite vector is always a zero vector, as the value of angle theta between the two is pi, which makes the value of sine pi as 0. Next, if the two vectors are perpendicular to each other, their cross product is the product of magnitudes of the two vectors and unit vector n perpendicular to both the vectors, as the value of sine pi by 2 is equal to 1. Look at the three mutually perpendicular unit vectors I cap, j cap and k cap. Cross product of I cap and j cap is k cap. On the contrary, j cap cross I cap is minus k cap. Next, the cross product of j cap and k cap is I cap, whereas k cap cross j cap is minus I cap. Similarly, the cross product of k cap and I cap is j cap, but I cap cross k cap is minus j cap. Also, the cross product of I cap with itself is zero vector, as value of theta between two identical unit vectors is 0. Similarly, cross product of j cap with itself is zero vector, and cross product of k cap with itself is also zero vector, as the magnitude of vector A cross vector B is equal to magnitude of vector A into magnitude of vector B into sine theta. It helps us to conclude that sine theta is equal to magnitude of vector A cross vector B upon magnitude of vector A into magnitude of vector B. The cross product is also associative with respect to a scalar. If A and B are two vectors and lambda a scalar, then lambda into vector A cross vector B is equal to cross product of lambda times vector A and vector B, which is further equal to cross product of vector A and lambda times vector B. Another property of cross product is distributivity of cross product over addition. If A, B and C are three vectors, then cross product of vector A and sum of vectors B and C is equal to cross product of vectors A and B plus cross product of vectors A and C. If vectors A and B are expressed in their component form, then their cross product is the value of the determinant in which elements of first row are I cap, j cap and k cap. Elements of second row are the scalar components of the first vector A, and the third row consists of the scalar components of the second vector, that is B. In this module, you have learnt that if theta is the angle between non-zero vectors A and B, then their cross product is given as the magnitude of vector A into magnitude of vector B into sine of angle between them into a unit vector n cap perpendicular to the plane containing vectors A and B. Vectors A, B and A cross B form a right-handed coordinate system. Cross product of two vectors is not commutative. Cross product of a vector with a zero vector is always a zero vector. If the cross product of two non-zero vectors is a zero vector, then the two vectors are parallel to each other. Cross product of a vector with itself is always a zero vector. Cross product of a vector with its opposite vector is always a zero vector. Vector product of two perpendicular vectors is the product of magnitudes of the two vectors and unit vector n perpendicular to both the vectors. I cap cross I cap is equal to j cap cross j cap is equal to k cap cross k cap is equal to 0 vector. I cap cross j cap is equal to k cap, j cap cross k cap is equal to I cap, and k cap cross I cap is equal to j cap. J cap cross I cap is equal to minus k cap cross j cap is equal to minus I cap, and I cap cross k cap is equal to minus j cap. Sin theta is equal to magnitude of vector A cross vector B upon magnitude of vector A into magnitude of vector B. Cross product is associative with respect to a scalar. Cross product is distributive over addition.